Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by locking the goal, one clear assistant skill like scheduling or reminders. Next, get minimal hardware, a Raspberry Pi 4, microphone, speaker, and basic servos to prototype quickly. Once done, install Python 3.10 and pick ROS for robotics or a lightweight Flask API if you want simplicity. This makes integration straightforward. Make sure to provision a USB mic and test audio input immediately, because working audio avoids wasted effort later and lets you iterate fast. You now bind voice to behavior, route microphone input through speech-to-text, use a local model for privacy or a cloud API for speed, then parse intents with a small intent handler. Once parsed, map intents to actions using a state machine or ROS topics so commands trigger predictable outputs. Next, wire motor drivers to GPO or a motor HAT and test movement with short, safe pulses. This prevents mechanical damage. Finally, log events so you can trace misbehavior later and refine intent parsing. You finish by hardening the assistant. Add confirmation prompts for risky actions and fallbacks when confidence is low, so the robot asks instead of guessing. Once done, build a minimal web UI or mobile endpoint for manual overrides and to push updates. This speeds recovery in the field. Then run systematic tests in noisy and low-power scenarios. If things go wrong, check logs and sensor latency first. Most failures are timing or confidence thresholds. Adjust thresholds and retry before rewriting code.
Thanks for watching. Consider subscribing if I helped unscramble your problems.